Hi, my name is Jonathan. Welcome to the SD-WAN Implementing Application-Aware Routing section of the policy section. So, SD-WAN enables you to choose between various transport networks. In addition to the static definitions, where some applications go over transport 1 and others go over transport 2, application-aware routing traffic enables you to transport to react to the performance of the transport network. All right? What we'll do is we'll evaluate the quality of experience of each circuit and match traffic to the best quality of experience we can give you. All right? So if this one has a little bit more jitter, we're going to send you to the other one that has a little less jitter for your voice traffic. And we can configure these policies to change transport if those performance metrics indicate that the original path is not providing the quality that you want. Especially when we're talking about very delay-sensitive traffic like voice. If we're routed over something that's not going to give us a decent voice quality, but we have a circuit that does meet those requirements, we're going to move that traffic over there automatically. And yes, we are going to optimize our voice path. Okay. So we're going to talk about application-aware routing with DPI, which is Deep Packet Inspection, which is going to monitor those applications in use by devices in all the VPNs on all the subnetworks in which they're connected. And we're going to talk about how to implement this policy. So, how does application-aware routing work? Applications are going to require a certain connection quality. Some applications are going to require low packet loss, others low jitter or latency. With AAR, V-edges can measure those key metrics for each transport and make routing decisions based on those metrics. So we have to define those metrics. The metrics that are available to us are delay, packet loss, and jitter. If you're not familiar, jitter is variable, unpredictable latency in packets. So, for instance, here we have 3 paths, okay, with a certain latency, packet loss, and jitter. Just an FYI, any packet loss at 3 is bad. 3% here was basically down. I would call my carrier. So what we can do, though, is I can say that we have a path, set up a path requirement of less than 150 milliseconds, loss of less than 2%, and jitter of less than 10 milliseconds, and then we measure each link by probing it to see if it meets those SLA requirements that we've set. All right. So, for instance, we're going to create a poll interval. We're going to basically poll the link. If you're familiar with IPSLA, which uses a probe across a link to determine its health, this is very similar. So we're going to define a poll interval and a multiplier to determine how fast a potential failover is executed. We're only looking at service-side traffic from the VPN, so we're not probing the inside. We're not probing everything else. We're only probing that service-side traffic. Then the path is going to be selected. Selection is going to be defined as follows. If a single tunnel matches the SLA, send data traffic through that tunnel. If 2 or more tunnels match, distribute the path traffic among them. If no tunnels match the SLA, send data traffic through an available tunnel. Note that if 2 tunnels match the SLA, the load is distributed, so we do equal cost multipathing. All right? So we do 2 checks on the transport path for the liveliness and quality. So the parameters that are determine that quality of transport are as follows. We have a hello interval of every X milliseconds a probe is sent. For example, 1,000 milliseconds is the default. So we send one every 1 second. Okay? And then we have a poll interval. How many times over this time, this long period of time, is the average path quality is going to be determined? The poll interval defines indirectly the number of probes to send, i.e. 10 minutes is the default. So if I'm sending a probe every 1 second and my default is 10 minutes, okay, that defines how many probes we're going to be sending. Okay? So in this case, it's going to be 600. 60 times 10. The preceding process is going to be done some number of times. That's that multiplier. All right? And average path quality will be established, and that routing decisions are going to be made on this average path quality measurement. And then we retain the previous 6 poll interval calculations. So basically, each V-edge router is going to send a BFD hello packet. This is that BFD. BFD stands for bidirectional forwarding and detection. Going to send a BFD hello packet for path quality and liveliness detection. and packets are echoed back by the remote site. The hello interval in the multiplier determines how many BFD packets must be lost to declare the IPsec tunnel down. The number of hello intervals within the poll interval determines the number of BFD packets considered for establishing poll interval averages path quality. An app-wrap multiplier determines the number of poll intervals by establishing overall path average quality. All right? So we're going to send a bunch of packets across, get a bunch of packets back. We're going to get a determination of quality based on those responses. Okay? So how do we set this up? Basically, we're going to set up an SLA, which is a service level agreement. Basically, that's the standard we want to hold that circuit to. And the agreement with the carrier, if they don't meet their SLA, usually means we don't have to pay. Then we're to define our application lists, define our sites, prefixes, and VPNs, define the policy, and then apply that policy to the sites. So here's an example. We're going to define an SLA class to measure against. In our example, we configure 300 milliseconds latency and a maximum packet loss of 3%. It's for web traffic, so I guess that's good enough. Okay? So down here, we're creating our policy, our SLA, right? 300 milliseconds and a loss of 3%. Okay? It's TCP traffic because it's web traffic, so a loss of 3% is fine. We'll just retransmit. Okay? So this policy defines we're going to match an app list called web, right? And our preferred color is biz internet. So if we're meeting that requirement, we're going to send it out biz internet. However, if the requirement fails, if we fail to meet that requirement, then send it out MPLS. Okay? And then we're also, by the way, just to reference this because these need to be referred to, we do have VPN lists here that we're looking at VPN 10 traffic. And this policy is going to get applied to site IDs 3 through 5. And then again, we apply the policy. So as we move more and more traffic to the internet as software as a service, more Office 365, more cloud-based applications that are using web traffic in the cloud as opposed to at data centers, internet traffic might have a priority. If you're a travel agency and you're using booking applications that are all in the web, right, that web latency may have to meet a certain amount of requirement. We're going to want to use our local internet connection, but if that's not providing it and sessions are timing out, we're going to want to route it over a higher quality circuit, that MPLS in this instance. Okay? And notice that we're referring to colors here, right? So we're not referring to actual individual tunnels. We're saying color. So your site has a biz internet circuit, it's local internet, and it's connected to the MPLS. So you got both circuits. So that we're going to prefer the biz internet for this web traffic, right? And remember, the app family is defined here. So the app list is web, and we're referring to app family web, which means 80/443. In summary, basically, we've talked about application-aware routing, monitoring those transport links for their health, loss, delay, and jitter, and then being able to configure those links to be chosen or preferred based on those metrics. So if a circuit is not meeting our SLA, we can fail over to another one. This gives us a lot of advantages. We're still able to do this on Cisco routers with the IPLS SLA command. It's the amount of configuration we have to do after that that's where SD-WAN really shines. In the fact that we can actually do that and push a policy globally to all sites saying, hey, if this your primary circuit is not working the way it should, use a backup circuit. Okay? Thank you for watching the AAR video, and stay tuned for the NAT video.